и заслушать сейчас последний доклад на сегодня. Доклад тоже наших зарубежных коллег, который нам представит Грета Бранкалеони.
Добрый день.
Добрый день.
Hi, I'm going to speak in English if it's not a problem because I don't speak Russian, so yeah, my presentation will be in English. And I won't be long because I know that there it's very late in the afternoon, so I'll try to be very quick. Can you see the presentation?
Yes.
Okay, great. So hello everyone, I'm Greta Brancaleoni, a PhD student at the Polish Academy of Sciences, and I work under the supervision of my supervisor, Maciej Krajcarz, and I work in his project called stratigraphy and depositional and post-depositional processes at Paleolithic archaeological sites in Central Asia. So as a part of this bigger project, last year I was in Kyrgyzstan and with our Russian colleague Svetlana Shnaider and also Sultanat Alisher, kyzy, we worked mainly into Obishirian sites, Obishir 1 and Obishir 5. So today I'm gonna show you the methodology we applied, but about the results, I'm gonna show you only the Obishir 1, the results from Obishir 1. And so I'm gonna show you a map. As you can see, we are in Central Asia, on the southwestern part of Kyrgyzstan, just at the foothills of the Alai mountain range. So very close to Fergana Valley, actually, the Alai range just borders the southern margin on the Fergana Valley. It's a fertile valley, very important for this region. And we obviously are very close to the border with Uzbekistan. So this red rectangle is our study area. And yeah, three main structures are in the region: the Fergana Valley Basin, as I told you before, the Alai Range, and also called South Asian in this part of the orogene. And further to the south, we have the Pamir orogene. And we are very close also with the China borders. If we look into much more detail, so here you see a map of the Kyrgyzstan in Russian, if I'm not wrong. And this basin is characterized by small urban areas, as you can see here, and the most urbanized area is Kyrgyzstan. This Aydarkan is very famous because since 1940s has been exploited for its mineral resources like mercury and antimony. And in fact, you can see also here very clear some tailing pipes. You can see that the Ashmeto ridge was very, very exploited, and it's visible from satellite images. So, but also in this map, I put some dots, and these dots are archaeological sites. So the pink dots are Obishirian sites. Obishir 1 and Obishir 5 are showed here only. And there's also Serungur and Selungur. As you can see, they are just in line. They are both in line, and they are in line with the foothills of the Ashmeto ridge. So it means they actually share a similar geomorphological setting. I'm gonna show you the setting later on. Now I just wanted to tell you about the land use. It's mainly agriculture and pastoralism. As you can see, the valley is drained by the Obishir River. It's a temporary braided stream. Its outflow is only during the season after the spring season and early summer, because it's recharged by snow melting from the Alai mountain range that is just to the south of this area. Now, but a little bit about history. These two sites, firstly, they were discovered by the archaeologist Islamov, and during the mid-20th century. And after his discovery, they started to study the sites during 3 season campaigns. And thanks to the Soviet scholars, actually, from these sites, we have a big collection of around 2,000 artifacts. And also, only by comparison with other technological complexes, they were able to attribute these 2 sites to the final Pleistocene, early Holocene. But there were some problems because the artifacts they found, they hadn't been referred to the stratigraphic unit. So in 2016, a joint Russian-Kyrgyzstan expedition was organized just to restudy these sites with modern excavation techniques and also with modern laboratory methods. Here, I want to show you the planimetry of the scholar, the Soviet scholars. So we have Obishir 5 here and Obishir 1 here. From this planimetry, it's quite clear that they are just in front of the limestone outcrops. And now I'm going to show you a nice 3D model. So you can see here Svetlana Shnaider did this model with drawn imageries. And you can see that these two Obishirian sites are just in front of a very steep cliff built in limestone. This is Paleozoic limestone. And also this limestone is very karstified and fractured. The joints are very visible, but the karstic features are not, I'm sorry. But believe me, there are rock shelters. There are several rock shelters, and these archaeological sites are just in front of these niche, these great grottos. And you can see also that at the foot of these cliffs, there are quaternary infills. And they are just made up of scree deposits. So the coarser material is coming from the cliff just by rock avalanches or rock falls. And we mapped the scree deposits together with the terraces, and we tried to understand the mutual relationship between the scree deposits, the cliff above, and the terraces. And we can just synthesize the relationship with the Shnaider schemes. Shnaider studied talus deposits in the Alps, in the eastern part, if I'm not wrong. So we are in the distal slope because our slope is ranging between 10 and 15 degrees. So we are in the distal slope, and our 2 sections mainly are talus apron and talus cones. Now a little bit about the methodology we applied. So first of all, we tried to decipher the macro structures, and we produced these not nice profiles. So we described the stratigraphy as with a common stratigraphic approach. And we tried also to figure out if there were some erosional surface, so some unconformities, because they are important when it comes to redepositional processes. And this is the eastern profile, Obishir 1 archaeological trench. And this is the southern profile. And we recognize an erosional surface at the boundaries between Unit 1 and Unit 2. Overall, we distinguished the 6 stratigraphic units from 1 to 6. 1 is the top, 1 is the bottom, 6 is the top part of the profile. And also we collected bulk samples, namely, in particular, number 8 samples, and we ran grain size analysis and basic geochemical analysis. So thanks to the grain size analysis, we found out that the material is poorly sorted, that it matched this scheme. So at the distal slope, the material is poorly sorted. And also we have a slightly coarsening up tendency going upward. These tendencies is really slightly, because we are going from sandy silt to silty sand. So the difference is really little. Here some data from the geochemical analysis. So here we see the organic carbon and organic nitrogen. And we see that from the top to the bottom, the organic carbon is decreasing as well as the nitrogen. If you remember, the Unit 6 is the topsoil. So it makes sense that it's decreasing, that this Unit 6 has the highest amount of these 2 organic compounds. And also we see that the concentration of carbon and phosphorus, these 2, carbon and phosphorus, are coming from ICP-MS, so couple mass spectrum. Furthermore, we collected number 5 monoliths oriented. So we produced 10 thin sections and we analyzed them with common micromorphological approach, like for example, Stoops 2003. And from this analysis, we can say that the main post-depositional process was bioturbation or still ongoing. And also quite important is that the boundary of Unit 1 and Unit 2, there are charcoals. So the boundary is marked by this charcoal, by the presence of charcoals, and some redepositional process possibly occurred because we have grain, we have the class coated by silty clay cuttings. And we also see that going upward, the calcite infillings are increasing, as well as bioturbation structures. For example, in Unit 3, we have very coarse termite burrows. We can see very clear the walls that are compacted, and some very complex microstructures comprising aggregates, including fragment bones. And yeah, it's very complex, and we attributed this microstructure to bioturbation processes. Also, we can see that the Unit 4, the Paleozoic, before the slam of excavation, it characterized by very coarse bone and coprolites. and some burned features. So we were able to describe the profile in these terms. Then also mollusk samples were taken during the excavation. And here you can see a graph just showing the frequency. So the most frequent species, it's on the top, and less it's on the bottom. We have more than 50 specimens only for two species, and then we have less than 50. But we tried as well with some clustering. So here there's a heat map showing the relative abundance within samples. Here we have the archaeological horizons, and here the macro units. So as we can see from this cluster here, coming from Connie's clustering, we see very clear three main clusters. So, and they are matching slightly the macro units. So for unit 1, we have this cluster here. For unit 2, we have this one. And for the uppermost units, we have another cluster. Also, we collected OSL samples, and we made an age depth model. So these deposits, these quaternated deposits, just started to accumulate it in the upper Pleistocene, and there is the transition. It's not clear where it is exactly, but the transition between the upper Pleistocene and the lower Holocene, we put it here between unit 2 and unit 1. And yeah, we didn't took OSL samples in the Islam of them, because we actually possibly know the age of this one. And at last but not least, we have the Obishir assemblage that the main layer 3 was characterized by the most abundant assemblage that it reflects the final Epipaleolithic and early Neolithic technological complexes. So 10,000 from 10,000 to 7,000 calibrated BP. And spasiba. Spasiba, and I've finished. So thank you very much.
Спасибо большое за доклад. Вопросы? Уважаемые коллеги.
Thank you, Greta.
Thank you.
Спасибо, Глеб.